Alright, in this video, this is going to be a roughly 25-minute video from over a 1-hour free Facebook Live session that I did in my TEAS math group. If you have not joined that, go ahead and click on the link in the description to join that Facebook group for even more free live sessions. The first part of the video talks about the updates to my TEAS math workbook as well as my multiple choice math quiz, but the bulk of the video is us doing some word problems that are TEAS math related. So without further ado, let's go ahead and get started. If this is your first time doing a live session, this is the third one I've done since I started this Facebook group in September. Before we dive into some problems, we do have some problems we're going to look at tonight. I want to talk to you about a few things real quick. For those of you who have purchased my workbook, I have a TEAS math workbook. I'll show you where you can find it. I just released a new update today, and I'm calling it version 3.0. Just to give you a preview of what that looks like, I'm going to load it up. And this is the TEAS math workbook. There's a lot of pages to it. A good chunk of it is actually handwritten solutions. And if you once you purchase it, you download it, you have instant access to it. As soon as you pay for it, you can download it. And I recommend opening it in a PDF reader, like Adobe Acrobat Reader, or the default app on MacBooks, MacBook Pros, is something called Preview. And when you open that up, you want to try to find this sidebar, which is like your table of contents, and you can easily navigate through the workbook. So notice, like right here, math problems, section 1, fractions, decimals, and percent. As soon as I tapped on that, it jumped to it. If I wanted to jump later on into the workbook, say the last section, geometry, boom, it jumps straight to it. So that's what I recommend for those of y'all that do have the workbook. I've seen some questions posted. I get a lot of questions when people buy it. They're like, hey, can I print it out? Frequently asked question. Absolutely. Once you pay for it, you can do whatever you want to do with it, except share it. But some other things too. Navigating the workbook like I'm doing over here. The solutions are just as easy to get to. For example, that section 1 we saw a moment ago, section 1 right there, we jump straight to it, and then you have your handwritten solutions. And there are also 2 practice tests inside of the workbook. Something else to take note of to see I'm fairly active with keeping this book fresh. I originally released it in March of 2019. There was roughly a little over 250 problems. Now there's over 1,000. But in March of 2019, and you can see I made frequent updates, and then the most recent one was today. Literally today is when I uploaded the new file. Every time I update it, you get a brand new email with a brand new link to download it. And Jackie, you are saying yes, you can download that new workbook, the new update. You should have got an email saying, hey, there's an update. And with this update, for those of you that have used this, there's not many of us in the live session right now, but I was hoping we'd have a few more people. There are quite a few things that are different. Now, I haven't removed anything, but some of the new stuff, drill and practice. Drill and practice is something new I've added to the workbook, and it's essentially a bunch of questions, but they're very, very similar. For example, adding fractions. I put several of them right there back to back to back to back so that you can practice that technique repeatedly. And then if you ever had to add fractions, or other examples would be proportions, you can just do those things really quick without even having to think twice about it. So it's for you to hammer those skills down, drill and practice. And then there were some additional problems added to the workbook as well. So enough about that. Where can you get it from? Over at my website. If you have not been to www.bcraftmath.com, couple of things. ATI TEAS underneath the math tab. That's where all of my TEAS resources are. And the vast majority of this stuff is free. So take advantage of that. But then if you go to the store, that's where you can get the workbook from. And then something else I've released back in September is a TEAS math multiple choice quiz. This is different than the workbook. The workbook is what I just showed you. The multiple choice quiz is just straight up. There's over 100 multiple choice questions. I'm adding new questions to that quite often. To get a feel for this, try the free sample right here, completely free. Try that out. If you like it, it'll give you the answers. It'll give you feedback, just like my workbook does, except it's just straight up multiple choice questions. So those are 2 products that I have that are not free. Everything else that I do is pretty much free. Now, the mini sessions hang out towards the end. I will post a link. Some of you who are in this group right now, some of you who are live with me right now have attended some of my mini sessions. I will have another one planned for next week. And before we finally jump into some problems, I do have some problems set up. Let me show you this as well. There is a way that you can search my TEAS page or my YouTube channel. If I go back to my TEAS Math website, bcraftmath.com/ATITeas. If you are on a Windows computer, you will hold Control and tap F. If you are on a Mac, you will hold Command and tap F. Check out what happens if I do that. Hold Command, tap F. Here's what pops up, a little search menu, and you can type in whatever you want. So suppose you are looking for something with fractions. If I type in the word fraction, that pops up 15 times on this page. And if I use the arrows, I can actually go to those specific spots to find those videos. And all of these are videos, by the way. You know, you go click on these, it's going to take you straight to YouTube. I recommend using my website, and then from there, it'll take you to my YouTube channel. However, one more thing I'll show you as well. If you do go to my YouTube channel, now this is specific to my channel. So what most people do when they go to YouTube, they search up here. Well, if you actually go straight to my YouTube channel and you look for this magnifying glass right here, if you type something in that spot, it will search just my channel. For example, if I typed in, let's do area, because that's something you'll have to be doing. And look what pops up. Geometry, area and perimeter, TEAS Math Tips, video number 11, the area of a complex shape. So that searches just my channel. It really does narrow things down for you. So that's how you can quickly search both my website. And remember, that is either Command F on a Mac or Control F on a Windows. And then you can type in whatever word you want, and then how to search my YouTube channel specifically. So I'm going to pause for a second there. I'm going to catch up on the chat. And if you have any questions, go ahead and leave those. All right. So the goal for tonight, what are we going to do tonight? We're going to do some word problems. And this is going to be a little bit different than the mini sessions I do. The mini sessions that I do is I put a problem on the screen and I let you work it out. And then we talk about it together. But since, you know, I can only read chat, you know, we're not talking back and forth. So I'm going to put a word problem up here. I'm going to let you read it. And what I do with my mini sessions is I give the students 1.5 minutes to 2 minutes to try and answer the question. I'm still going to give you a little bit of time, but not as much time. That way we can cover all of these questions in 30 minutes. But have a look at this first one. Think about it for a little bit. I'm going to come back in a few seconds and provide some feedback. Now, for this particular problem, we're trying to figure out how old Sarah is, but we got 3 people that we're worried about. We got Sarah. She's 5 years younger than her brother John, but Sarah's also 6 years older than her sister Cameron. So we have Sarah, we got John, and we have Cameron. Now, the one we're trying to figure out is Sarah. So one approach we can do here, you will have multiple choice on the TEAS, but let's take an algebraic approach, like the real way you would do it if you did not have multiple choice. So I'm trying to figure out Sarah's age. How old is Sarah? I'm going to call Sarah's age X. I don't know. I'm trying to figure it out. So that's going to be my unknown thing that I'm trying to find. Well, what do we know about John? So it says Sarah is 5 years younger than her brother John. Now be careful here. John is older than Sarah because it says Sarah is 5 years younger than John. Therefore, if Sarah's age is X, we would have to take Sarah's age, which is X, and we would have to add 5 years to that to get John's age. Again, if Sarah is X years old, we would have to add 5 years to Sarah's age because she is 5 years younger than John. Now, what about the next piece, though? Cameron. Sarah is 6 years older than her sister Cameron. So Cameron's younger than Sarah. What we would do here for Cameron's age, we would take Sarah's age, and since Cameron is younger, we would subtract 6 years. We're subtracting 6 from Sarah's age, And now look at all three of these pieces. We have everything in terms of X, and X represents Sarah's age. Now look at what it says. The sum of all three of their ages is 65. So we would take Sarah's age plus John's age plus Cameron's age, and we would set this equal to 65 because the sum means we add them all up. So let's add this up. Let's solve this equation. Over here on the left-hand side, we can combine like terms. We have those x's right there. So x plus x plus x, that is 3x. And then we have 5 minus 6 also over here on the left-hand side. If we take 5 minus 6, we get -1, and we set this equal to 65. So now we have an equation where we can get x by itself rather quickly. Let's add 1 to both sides. Trying to solve for x. And this leaves us with 3x is equal to 66. Finally, to get x by itself, we're going to divide both sides by 3. 3's cancel out. 3 divided by 3 is 1. So therefore, we have x is equal to, and if you take 66 and divide it by 3, you get 22. Now, what does this represent? Let's go back and look at how I set this up. We let Sarah's age be x. So we got x equals 22. Well, that is the answer to our question. Since we let Sarah be x, Sarah is 22 years old. Now, let's check our work though. Let's see if this makes sense. So we said Sarah, she's 22. Now, what do we know about John? Sarah is 5 years younger, so John is older. And remember, we took Sarah's age plus 5, so 22 plus 5, that means John's 27. And then one more piece here. Sarah is 6 years older than her sister Cameron. Well, we said Sarah's 22. If Cameron is 6 years younger, cause Sarah is 6 years older, if we subtract there, what are we going to get? We'll get 16. And let's add these three ages up. I'm going to load up my calculator. If we take 22, Sarah's age, plus her older brother John's age, plus her younger sister Cameron's age, look at what we get. The sum of all three of those ages is 65. So that's an algebraic approach to that word problem. I'm going to pause for a second, let you soak that in. Feel free to ask any questions in the chat. Is this the only, okay, so Jacqueline is setting up an algebraic. I mean, there are definitely other ways of doing it. You could guess and check. I mean, guessing and checking, Jacqueline, is always a technique. And if you do, like on the TEAS, you're going to have multiple choice. So I'll tell you what I'll do. For this next question, I'm going to give you some multiple choice. Read over this. I'm going to make up some answers real quick, and we can use these to help us out in terms of not trying to solve it, but maybe using the answers to help. So read over that. I'm going to come up with some multiple choice answers. So we got a bunch of random numbers up here, and it says a donut shop sales for the week consisted of selling donuts, coffee, and scones. The total sales for the week was $10,524. If 45% of the sales came from donuts and 36% came from coffee, so we got 45% for donuts, 36% for coffee, how much in sales did the scones generate? And I see an answer over in the chat for A, and that is correct. So sometimes, and this is a prime example where you probably didn't look at the answers first. You probably actually tried to work it out. Let me show you one approach, one of many. I could sit here for the rest of the night and talk about this one problem and all the different ways to do it. The 45% is the donuts and the 36% is the coffee. So if I look at these two percentages together, if we add those, 5 and 6 is 11, so we get 81. So 81% of their sales comes from donuts and coffee. The rest comes from the scones, and the scones is what we're interested in. So if you think about it this way, if we take 100% and we subtract off the 81%, This will tell you the percentage that you have left, and that percentage there is the scones. Again, just one way. And now from here, all we have to do is find 19%, 0.19, that's 19%, of multiply the total sales, 10, 5, 24, and boom, there it is. That's just one of several ways. Now, some of you might have done it differently. Here's what some of you may have done. Let's go back to this 81%. Let's find 81% of the total sales. So 0.81 times 10,524. This dollar amount, 852. Let me write that down so I don't forget it, because I'm going to come back and do something right here in a second. Now, bear in mind, how did I get that number? I took 81% of the 10,524. This dollar amount represents how much they made from donuts and coffee. So what we could do is we could take the 10,524 and subtract that off to figure out what was left. So if I subtract off 8524.44, boom, check it out. Same answer, a slightly different approach to get there. So the correct answer there would be A. Feel free to chime in with some questions. I do see where 3 of y'all did say A. That's good. All right, so there's 2 word problems. I'm going to go on to this third one here and read over this. I'm going to give you some multiple choice answers to try as well again. All right, so I'm seeing 2 answers that are D. That is correct. Let's talk about this. Now, I want to explain this to you. So obviously you would not be doing all of this on the TEAS test. I mean, because it's time, but I want to teach it to you. I want to explain to you my thought process for this problem. If I were to just put a little square up here, and if I said that this was a 1 inch by 1 inch square, if we were to find the area of this, let me erase that, that's ugly. 1 inch by 1 inch. If we found the area of this square, we would take 1 inch times 1 inch, and that's going to be equal to 1 square inch. And a common way you can write it is you can put inches with a 2, or you can write the word square. Now, let's read this problem. That's 1 inch on a map. But what does that actually represent in real life? This 1 inch on the map actually represents 50 feet in real life. So that 1 inch on the map is 50 feet in real life. So therefore, this would be 50 feet by 50 feet. Let's find the area now in square feet. So we would take 50 feet times 50 feet, and we do get 2,500 square feet. Now, why am I doing this? Because let's look at this question. It says, if the area of the department store on a map, or a department store on the map, is 6 square inches. See, this doesn't say just 6 inches. It says 6 square inches. And notice I did get my square inches down here. So what I'm going to use is I'm going to use a proportion here. I'm going to take 1 square inch. That's the same thing as 2,500 square feet. Let's go back and look at this picture I drew. 1 inch times 1 inch. That's on the map. That's 1 square inch. But in real life, that's 50 feet by 50 feet. So that's 2,500 square feet. So here is our conversion that we want to use. 1 square inch is equal to 2,500 square feet. And then now we can come in and put this 6 square inches. Notice I'm putting that over here on this side because I did set up my square inches on the left. And we are trying to figure out how many square feet it is in real life. And the thing with proportions, you cross multiply and divide, drill and practice that concept. I mean, this one is pretty quick, but a little tip, I've mentioned this in all my mini sessions. When you have a proportion, go ahead and multiply the 2 numbers that are not with the X. The 6 and the 2,500 are not going to be with the X when we cross multiply. So I'm going to go ahead and multiply those together, we get 15,000, and we don't have to divide by 1 here, folks. I mean, there is a 1 times x. But if this number was a 2 or a 3 or a 4 or something like that, you would want to turn right back around and divide by that number. Here, again, we don't have to because it's just a 1. But notice here, we do get 15,000. So therefore, on that map, 6 square inches on the map actually represents 15,000 square feet in real life. Now, some of you might have known automatically, probably, maybe, I don't know. Those of you that did answer this question correctly, once you know that 1 square inch is 2,500 square feet in real life, since you have 6 of those square inches, all you really have to do is multiply by 6. So, just a different approach there. All right, and let's go ahead and knock out one more, and I'll hang out once we do this, and I'll answer a few questions. So, number 4, percent of decrease. So, for number 4, Chris is on a strict diet where he can only consume 1,500 calories in a day. Prior to starting the diet, he was consuming 2,200 calories per day. What is the percent decrease in Chris's calorie intake? Probably should have said caloric or whatever, but it'll be all right. So his calorie consumption is going down. It used to be 2,200, and now it's 1,500. So key thing here, I don't care whether on the TEAS, you're probably going to have a question that either mentions something about percent of increase or percent of decrease. And I didn't spell that right. Percent of increase or percent of decrease. The formula is the same for both of them. And I am seeing some D's and some B's. I'm going to go ahead and tell you one of those is right, but hang tight and I'll show you which one it is. Percent of increase or decrease, same formula. And here is that formula. I'm just going to kind of type it out in some steps. The first thing you want to do to find percent of increase or decrease is step 1, find the difference between the two values. So let's go ahead and do that. Step 1, find the difference. We got 2,200 calories. We subtract 1,500 calories. That is a difference of 700 calories. So he's actually consuming 700 less calories per day. Now, once you get that number, step number 2, take that difference and divide by the original. Here's where you have to be careful. The original is what it was before it changed. So the original in this case is the 2,200 because that's what he was doing prior to starting the diet. Take the difference, 700. We're going to divide that. I'm just using a fraction bar there. And we divide that by 2,200. Let's bang that on the calculator. So 700 divided by the original amount. The original consumption was 2,200 calories before he started his diet. And if we divide that, we get this funky decimal here. So let me just copy that over. And we get 0.318181, blah, blah, blah. Now, I know you don't want a lot of steps, but these are your 2 main steps. The next thing you want to be careful with, though, is just remember to convert the decimal to a percent. So in this case, anytime you have a decimal, you can convert it to a percent by moving 2 places to the right or multiplying by 100. Same thing. Anytime you multiply a number by 100, all you're really doing is moving the decimal 2 places to the right. So if we move it 2 places to the right, we'll get 31.8% approximately. And we'll just go ahead and say the closest answer we have up here is 32%. And this is a decrease in his calorie consumption. So therefore, B is our answer. Do the instructions have to say round or do we automatically do it? Okay, Nick, Vic, what I would say there, it might not tell you to round, but if none of your answers actually match, like we got 31.8%, the closest thing that we have up there in the answer is 32%. I mean, maybe I could have put in the directions round to the nearest percent. There you go. And what Caitlin said, she usually rounds percentages unless the answer choices have decimals in them. That's a good plan of attack right there. Okay. And Nadia, that is a good point to make. The question says, and don't get too twisted over on this, but since it says what is the percent decrease, since we've already established, the question has already established that it is a percent decrease, you really don't have to put that negative in front of it because we have already said it is a percent decrease. How much is it decreasing by? 32%. All right, ladies. Well, I am going to sign off. I'm going to post the notes, post a link. Y'all take care. Tag me with any questions in the group. Have a great evening.